The last concept that we're going to cover for exponentials are the interest formulas. Now, surprise, surprise. This is truly a surprise because I am going to give you these formulas for your test. But you know I never do give you any formulas ever, but these interest formulas I will give you on your test. So you don't have to worry about memorizing those. This will be something that you are given. However, you are going to have to know what all the variables mean, and that's what we're going to go through right now. So I'm simply going to give you the formulas, but you have to know what these variables mean. So the first one is compound interest, and the second one is continuous compounding. For both of them, the A value here represents the amount in the account. So that's what you have in your account once you figure out your interest. The P is what you start with, and that is called principal. So the principal value, which is what you start with. Cool. Then you have, for this top one, you just have your number 1 here, so that's just a number. Then R for both of these is a rate. Now, rate is a percent. In order to work these problems, you're going to have to take your percent and convert it to a decimal. When you convert it to a decimal, that's what you use in your formula. Then I have a T over here, and your T value for both of them is time. And specifically in this one, the time is measured in years. So if it says half a year, then you have 0.5. So it has to be in terms of years in order to work this out. Now we've got a couple of variables that we have not identified at this point. This E on the continuous compounding is a constant. It's called the natural exponential. And just like pi, it's a number that occurs all the time. 2.718 ... And it goes on and on forever. So E is an exponential. If you look at your calculator, it is the second key to your caret key typically because it's your exponential. On the top, you have this N. This N represents the number of times this is compounded. So the number of times this is compounded, for instance, if it says quarterly, which is like the problem we're getting ready to do, that you know is 4 times a year. Semi-annual is 2 times a year. Annually is 1 time. So compound interest tells you how many times that is being compounded over your year. All right? Let's put some of these into action then. So here's our first problem. Suppose $1,000 is deposited in an account paying 4% interest per year compounded quarterly. Find the amount in the account after 10 years with no withdrawals. And then we want to know how much interest is earned over that 10-year period. So the first thing we need to identify is what these variables actually are. First of all, my tip-off here is compounded quarterly. So I know that I am using the formula A is equal to P times 1 plus R over N to the NT. Now remember, I'm going to give you this formula. You're going to have to know which formula to use and what all the variables represent. So that part's on you, but the actual formula I will give you. So if I'm looking at this one, I know that my principal here is the 1,000. My rate is 0.04 because you're taking that decimal, or pardon me, you're taking the percent, putting into a decimal. And I also know that my compounded quarterly here is a 4, and that represents N. After 10 years, that's going to be my t. So here's the moral of the story. Take all this information, plug it into your calculator, and get the value. We want to know the amount in the account. That's still my variable. My principal is 1,000. Then I have 1 plus a 0.04 over 4 to the 4 times 10. Now here's the key to your calculator. When you have a calculator, you have to make sure you watch those parentheses. If you are dividing or something within parentheses, think about your order of operations. Also, when you do your caret for the exponent, you either have to put parentheses around those or just in your head do 4 times 10 is 40 and take it to the 40th power. So you'll have to put your caret in between there to take this to that exponent and work it out. All right, so go ahead and plug that into your calculator. Let me know what you get. All right, did you get A is equal to 1,488.86? Now keep in mind, what are we talking about here? Money. So I'm not going to tell you what to round this to. You're talking about money. So you're going to round it to the cent whenever you look at it, because that's the common sense part. So if A is $1,488.86, look at part B. How much interest is earned over that time period? How do you figure that out? Yeah, if you start with $1,000 here and you end up with 1,488.86, do the subtraction. You earned $488.86 in 10 years. Cool. That's what you're looking for there. Keep in mind, this is a 4% interest compounded quarterly, so only 4 times a year is whenever you earn that interest. That's about right. Let's try another one. What if I look at this a little bit differently? So we can be given all of our information, or we can step back and take another look at how this works. Becky must pay a lump sum in 5 years. So within 5 years, she has to come up with a certain amount of money. What amount deposited today, so the present value, at a 3.1% compounded annually, will grow to $6,000 in 5 years? So the moral of the story is, okay, so she's got to have a payout here in 5 years. I want to know, what do we have to start with so that it makes enough money in 5 years to make it a $6,000 payout? That's the question. Okay, so this says compounded annually. That's my tip-off that we're using this formula. And now plug in everything we know. We want to have the payout to be $6,000, so that is what we end up with. We want to end up with $6,000 because that's my payout. We know 5 years is my time, and we know at 3.1% interest, that is a 0.031. And we also know, this is our 5 years again, which is our T. Compounded annually means that N here is going to be a 1. So let's plug it all in. So I have 6,000 is equal to my principal, which is what we're trying to figure out. How much am I going to deposit? 1 plus a 0.031 divided by 1, because it's annual, to the 1 times 5 power. So for this one, we're going to do a little bit of figuring first, because my goal here is to get this P by itself. So I want to get rid of all of the business that's with it. Now look at all these ones in there. We can clean this up and make this easier to work with. So I now have 6,000 is equal to P. 0.031 divided by 1 is just 0.031. 1 times 5 is 5. So if I'm looking at this problem, I have 1.031 to the fifth. If I take that and divide both sides by a 1.031 to the fifth, I can plug that into my calculator. So do 6,000 divided by 1.031 to the fifth, and let's see what we get here. We get $5,150.60. So that means I have to come up with $5,150.60 if I'm going to put this in an account that earns 3.1% interest compounded annually, and at the end of those 5 years, I will then have $6,000. So that's my goal, is if I have to come up with the $5,150.60 up front. So this is something where you can say, this is everything I have. What are you going to get? It's also good to say, okay, so if this is the account I'm plugging this into, what do I have to come up with in order to get my goal of X amount of dollars? It's this also a good thing to look at it and say, okay, so if I plug it into this stationary account, what do I have to, pay for college in 15, 20 years, depending for your kids or whatever you want to look at. So that's also something to keep in mind. What do I have to come up with so I can pay for college? What's this interest look like? Those kinds of things. It's a nice little tool. All right, let's try one more. All right, so now look at what this one says. Suppose $5,000 is deposited in an account paying 3% interest compounded continuously. That's our key. For 5 years. Find the total amount on deposit at the end of 5 years. Total amount on deposit and total amount in the account mean the same thing. But your kicker for this problem, it doesn't say quarterly, it doesn't say annually, it says continuously. So that is my tip that I am using this formula. Area is equal to principal times e to the RT power. So let's do it right now. Because of the continuous, that's where we use that natural exponential. So again, let's label it. $5,000 is deposited, so that's my principal. 3% interest is 0.03. Compounded continuously, that's my E. And my time here is 5 years. So plug in what we've got. We're trying to figure out A. My principal is $5,000. E to my rate is 0.03. And my time is 5. So make sure, a lot of times on your calculators, you will automatically, anytime you put in the E, it automatically puts a caret. Or some calculators, if you do an E, it puts a box up on top. And that's what you put the value into. Because it's an exponential, it automatically sets you up for the exponential. So make sure that you have parentheses around these two, or you have that multiplication sign between them, and that's how it works in your calculator. Okay, plug that in and let's see what we get here. Looks like 5,809.17. So $5,809.17. For 5 years, how much money are you making on this? Yeah, $809.17 for 5 years. Cool. That's awesome. All right, great job. So this is what we need to know for exponential. Enjoy your homework.